ఆ, నువ్వు ఇప్పుడు క్లాస్ ఉన్న తర్వాత రా. రా. Okay, we have been discussing different definitions and their derivations, displacement thickness, momentum thickness, energy thickness related to boundary layer theory. And when a boundary layer takes place, formation takes place on a flat plate. So the imaginary definitions have been derived, and we got displacement thickness is 1 minus small u by capital U dy integrated from 0 to delta, and momentum thickness theta equal to u by capital U into 1 minus small u by capital dy integrated from 0 to delta, and energy thickness we got we designated by delta star star, and it is small u by capital U into 1 minus small u by capital U whole square into dy. So in this way, we derived these equations. And I told you, whenever a problem is given, by giving small u by capital, it's a boon to us. So such type of problems we will discuss today. And of course, high care is required when integrating these equations. See this problem. Here in this problem, you have to find out displacement thickness, momentum thickness, and energy thickness for the velocity distribution in the boundary layer given by small u by capital U is equal to y by delta, where small u is the velocity at a distance y from the plate, and small u equal to capital U at y equal to delta, where delta is the boundary layer thickness. And also calculate the value of delta star by theta, delta star star by theta. Okay, here you are required to find out first displacement thickness. What is the equation for displacement thickness? Displacement thickness delta star equal to 1 minus small u by capital dy integrated from 0 to delta. Now you are given small u by capital U value, which is y by delta, and that y by delta you substitute in the place of small u by capital, and then it becomes 1 minus small y by delta dy. And now you have to integrate this. So where y is available. So when integrated, see clearly it is integral dy, see it is y minus 1 by delta y square integrand is from 0 to delta. So in place of y, uh, first the upper limit is substituted, and then the lower limit is substituted and it is subtracted. So it will become delta minus delta square by 2 delta minus 0 minus 0. So in that way, we have the value of displacement thickness, which is delta v. Now you have to raise a question. You have to raise a question actually. So what do you mean by boundary layer thickness delta? So okay, uh, again momentum thickness theta is to be found out. So for that the equation you have to substitute the equation theta equal to integral 0 to delta small u by 1 minus small u by capital U dy. And in place of small u by capital U, you have to substitute y by delta. And substitute y by delta and integrate. Here, the second equation, which is momentum thickness equation, is a little bit involved than the previous equation. The previous equation where we had only one small u by capital U. Here, in this, you small u by capital U once and small u by capital U square, that is u square by small u square by capital U square comes. So therefore, the equation, the integration becomes a little bit involved. So you see this slide. In this, you have to substitute the value of small u by capital U is equal to y by delta. So when substituted, you carefully substitute y by delta in the place of small u by capital, and then the momentum thickness represented by theta is given by integral y by delta in the place of small u by capital U, and multiplied by 1 minus y by delta into dy, integrated from 0 to delta. Now it is expanded. It becomes y by delta minus y square by delta square dy, integrated from 0 to delta. So again, y is a variable. And in terms of delta, all the thicknesses are to be found. That means the displacement thickness is how much fraction of bound layer thickness, and momentum thickness is how much fraction of bound layer thickness, and again energy thickness is how much fraction of bound layer thickness. Where all these are linear equations, linear quantities. So in that way, in terms of delta, you will find out. So whenever integration is, for example, performed by and by mistake, if you got other than delta, other degrees, other than delta 4, then you have to assume that what should be what your mathematics done by you is wrong. So in that way, you can really realize. And of course, simultaneously, the numerical value has also to be carefully examined. So here, y by delta integrated from 0 to delta, and y square by delta square dy integrated from 0 to delta. So y by delta Integral y by delta. What is its value? One of you tell me. Where delta is a constant. Okay. What is integral y delta? Y dy? See, all these simple things are to be actually carefully done by you. See, because this is in online mode. Of course, you have to look each and every sentence, every step, and see when required more explanation needed for some steps. So, and in some steps, the mathematical knowledge has to be checked, and some in some steps you may have some doubt. So, in that way, in several ways, the steps are to be examined. From my side, if some explanation needed, I will give more explanation. If from your side, if any doubt is there, you have to raise. And of course, ultimately, it has to be solved. It has to be solved. It has to be uh, uh, examined, done carefully so that the correct value comes. And see, simply speaking, this is all mathematics and no such explanation needed. But only here, some fluid mechanics concepts are to be understood still, though it is mathematics. And such fluid mechanics concepts are to be uh, understood by you. And if not, you have to raise doubts. Why delta is not a variable like that? Like that, you have to raise doubts. Now you see energy thickness delta star star. Delta star star is equal to how in what way the energy thickness derived in what is the ultimate equation we uh, had while deriving energy thickness. The energy thickness ultimately we got uh, small u by capital into 1 minus u square small u square by capital U square dy integrated from 0 to delta. So again, in place of small u by capital y by delta, given y by delta is to be substituted. And here, 1 y by delta and 1 y cube by delta cube comes. So there, uh, of course, all these are whatever is, uh, the manipulations are very simple only because y by u by capital U is given as y by delta 1. And here, see delta star star energy thickness is derived. So y by delta, then integrated, it is integral y by delta dy. So it becomes y square by 2 by delta minus y power 4 by 4 delta. So when 0 to delta, the integrand, the limits are applied, it will become delta square by 2 delta minus delta power 4 by 4 delta minus 0 minus 0. Because everywhere where y is there, you have to substitute delta first, the upper limit, and uh, and then negative sign, minus, you have to substitute in the place of y everywhere, in place of y 0, the lower limit. So in that way, the integration has to be performed, and ultimately got delta by 4. And one more thing is asked: what is the ratio of displacement thickness by momentum thickness? So it is because it is a ratio and because both are linear parameters. So we get a constant 3. So delta star by theta. We here got 3, the value 3. So in that way, we are dealing with a little a small problem in boundary layer theory. And sometimes, and of course, many times, see the next problem which we have to take is it has been given in the examinations several times, and such problem. See here only it is there. Find. See the problem 13 point. Find the displacement thickness, momentum thickness, energy thickness for the velocity distribution in the boundary layer given by small u by capital U is equal to 2 into y by delta minus uh, y square by delta square, y square by delta square, or y by delta whole square. So here the velocity distribution is somewhat a parabolic distribution, a square profile has been given. And while substituting in displacement thickness and momentum thickness and energy thickness, you have to substitute everywhere in the place of small u by capital U, 2 into y by delta minus y by delta whole square. Now, what is displacement thickness? What is the value of displacement thickness we got? See, still people are, I think, entering. I don't know why they are. It is, if you do like this, there is no uh, no way you can understand, because I told you this is the toughest topic in fluid mechanics. In entire fluid mechanics, this is the toughest topic, I repeat. And therefore, here, see, toughest in the sense care is required while doing mathematics, first of all. And toughest in the sense concepts, fluid mechanics concepts related to boundary layer theory are also tough to understand. And of course, logic. There is a logic. If you can uh, understand it, it will be stored in the memory, your memory, permanently. So that is how. See, careful listening, careful working on the problems, careful practice makes you perfect all the times. Okay. So here I'm asking you, what is displacement thickness and in what way it is, of course, derived. What is the final equation for displacement thickness? Displacement thickness, momentum thickness, energy thickness. ఈ ఈక్వేషన్స్ కి మనం ఈక్వేషన్ డెరివేషన్ ఈ కాన్సెప్ట్స్ అలా డిస్ప్లేస్మెంట్ థిక్నెస్ కి కావాల్సిన ఈక్వేషన్ ఏంటి? See, I don't know here, uh, especially in this topic, in this boundary layer theory. So nobody has raised it out. Nobody has been responded. And see, if you understood, you have to respond. If you uh, uh, if you have not catch the concepts, if you have not understood, you have to raise questions. You have to stop. You have to interrupt by raising questions. So that way, the instruction should go, and not it should not be one-sided. Already, the fluid mechanics textbook in PDF form has been given to you, and you can refer that PDF textbook every time, anytime. Now I'm asking you, what is displacement thickness? What is the equation for displacement thickness? So unless that is written, you cannot substitute the given velocity profile. The given velocity profile cannot be substituted. Okay, displacement thickness is 1 minus small u by capital dy integrated from 0 to delta. Momentum thickness is small u by capital into 1 minus small u by capital dy integrated from 0 to delta. And momentum and energy thickness is small u by capital into 1 minus small u square by capital U square dy integrated from 0 to delta. So these are the equations, and you have to substitute. You have to write these equations once, then you can remember these equations. Now, in the place of small u by capital, you have to substitute 2 into y by delta minus y by delta whole square. You have to substitute. Here, high care is required while integrating and also while multiplying small u by capital in after substitution with the 1 minus 1 capital U if it is momentum thickness, and also high care is required while multiplying small u by capital with the 1 minus small u square by capital U square dy in energy thickness. And there is a square in energy thickness, and that square has to be performed. Okay, very careful. So the better you have to do this separately. For example, where small u square by capital U square is there, you better do u square by capital U square is equal to 2 into y by delta minus y by delta square whole square. And this has to be expanded. What is a minus b whole square? Okay, I'm asking you simple fundamentals. What is a minus b whole square? Okay. Okay. See here, after substituting in the velocity, in the displacement thickness, the value of small u by capital 2 into y by delta minus y square by delta square, you will have the displacement thickness delta star equal to 1 minus. Now I am substituting small u by capital 2 into y by delta, and because minus sign is there, we have to write plus y by delta whole square dy. And this will become c y minus 2 by delta into y square by 2 plus y cube by 3 delta square. And the integrand from lower limit 0 to upper limit delta has to be applied. and this will become delta minus 2 by 2 delta into delta square plus 1 by 3 delta cube by delta square. And after simplification, you get value delta by 3. So it is 1/3 of boundary thickness. And the momentum thickness and energy thickness are to be see the momentum thickness theta. Here high care is required. See, because small u by capital is outside 1 minus small u by capital. And everywhere where u by capital is there, we have to substitute 2 into y by delta minus y square by delta square. And after substituting, here the algebra has to be done first. It is like a minus or some a multiplied 1 minus a, like that one algebra is there. So it has to be done first. So what has been done here is 2y minus 2y by delta minus y square by delta square is multiplied with 1 minus 2y by delta minus y square by delta square. So that is done by like this 2y by delta minus y square by delta square. So it is multiplied with 1. So 1. And then it is again 2y minus 2y by delta minus y square by delta square is multiplied by the same, and a negative sign has to be used. And that is one way. But here, what has been done here is the second bracket has been expanded and the multiplication has been done. Now here, more care is required. So first, in the first bracket, 2 terms are there. In the second bracket, 3 terms are there. So on the whole, you get 2 into 3, 6 terms. 6 terms you get, because outside first bracket you have 2 terms, and in the second bracket there are 3 terms. 1 minus 2y by delta plus y square by delta square. So when these 3 terms are multiplied with 2 terms, you will get definitely 6 terms. So all these 6 terms have to be carefully written. For example, I multiply 2y by delta first with 2y by delta. If I multiply, you will get 2y by delta minus 4y square by delta square plus 2y cube by delta cube. Now, with the first term 2y by delta, the multiplication is over. And with the second term minus y square by delta square, if all the 3 terms in the second bracket are multiplied, then you will get minus y square by delta square plus 2y cube by delta cube minus y power 4 by delta power 4 du. So in this way, these terms are to be carefully, algebraically, we should get all the terms. Now, whether you simplify or not, integration has to be carried. So simplification has been done because there are uh, square terms, 2 square terms, and 2 cube terms, and one one term having power 1 and one term having power 4. And when simplified, you will get 2y delta. And there is minus 4y square and one more y square minus 5y square by delta square. And cubic term 2y cube by delta cube is there, and plus 2y cube delta cube is there, and it will become 4y cube by delta cube. And coming to the fourth degree, minus y power 4 delta power 4. So in that way, it is simplified. And Now you have to integrate. So integrating this, you will get first 2y by delta dy, which is 2 by delta into y square by 2. So that is integration of 2y by delta dy. And second term minus 5y square by delta square dy. So its integration minus 5 by delta square, which is a constant, into y cube by 3. So it becomes minus 5 by cube by 3 delta square. And the third term when integrated, which is 4y cube by delta cube dy. Now, when integrated, it becomes 4 by delta cube, which is a constant, and integral y cube by y cube dy, which is y power 4 by 4. And the fourth term when integrated, you'll get minus y power 5 by 5 delta power 4. And when the integrand lower limit and upper limit are substituted, because all the terms have y in them, the lower limit is of course 0, and only upper limit we have to substitute. And when substituted, it becomes delta square by delta minus 5 by 3 delta cube by delta square plus delta power 4 by delta cube minus delta power 5 by 5 delta power 4. And when simplified, this becomes delta minus 5 by 3 delta plus delta minus delta by 5. So now here the least count has to be found and the problem has to be simplified. And after simplification, you get 2 by 15 delta, the value of momentum thickness. And coming to energy thickness, what is the equation for energy thickness? Okay, tell me energy thickness. The energy thickness delta star star equal to U by capital U into 1 minus small u square by capital U square dy integrated from 0 to delta. See, this is a complex one for this. Of course, given velocity profile small u by capital U is equal to 2y by delta minus y square by delta square. See, what I suggest to you is to calculate small u square by capital U square separately beforehand, or after writing the equation for energy thickness, you separately find out once you write u by capital U equal to 2 into y by delta minus y square by delta square, and you find out u square by capital U square, small u square by capital U square, and which is 2 into y by delta minus y square by delta square into again the same term. So which is a minus b whole square. So in that way, you find out the value of small u square by capital U square and multiply by small u by capital again and integrate. That will become of that that will give simplicity, simple equations, simple simplification. And still more care is required while multiplication is done. Now it is here written u by capital into 1 minus u square by capital U square dy. And wherever small u by capital is there, the value of 2y by delta minus y square by delta square is substituted. And this has been done here separately in a different manner. The algebra is, I told you, is not unique. You can flexibly do your own algebra. So in that way, in the textbook, it is done differently. So the outside term 2y by delta minus y square by delta square uh, is kept as it is, and 1 minus now a minus b whole square, the uh, the formula has been applied, which is a square, which is 2y by delta whole square, which is 4y square by delta square, and minus 2a, which is minus 2 into 2y cube by delta cube, which is minus 4y cube by delta cube, plus b square, which is plus y power 4 by delta power 4. And again, the second bracket term has one negative sign outside, one negative sign, and that negative sign is incorporated into the terms in the bracket. And in that way, the second bracket has been expanded. And now the first bracket has 2 terms, and the second bracket has 4 terms. So when multiplication is done, you will get 8 terms. First two, for example, first one with first one term, when the all 4 terms are multiplied in the second bracket, you will get 4 terms. And with the second term in the first bracket, if all the 4 terms in the second bracket are multiplied, you will get 4 more. 4 plus 4, 8, or 2 into 4, you will get 8. 8 terms you will get. So all these 8 terms have to be written, have to be carefully uh, done. And you can do provide simultaneously the numerical values as well as the powers have been uh, carefully uh, calculated. So now with one 2y by delta means y square by delta square is multiplied. So you will get 2y by delta minus y square by delta square with 1. So either or you multiply first all the 4 terms in the second bracket with 2y by delta. So that has been carried out in whatever way you can do here. With all the 4 terms in second bracket, 2y by delta, with the 2y by delta, the multiplication has been done. Then you will get 2y by delta minus 8y cube by delta minus 2y power 5 by delta power 5 plus 8y power 4 by delta power 4. And now the second 4 terms, that is next, if y square by delta square minus y square by delta square is multiplied with all the 4 terms in the second bracket, you will get minus y square by delta square and plus 4 y power 4 by delta power minus minus plus y power 6 by delta power 6 minus plus minus minus 4 y power 5 by delta power 5. So in that way, you will get the multiplication into dy. And see if 2y by delta is there, any more y terms are there, check, no y term. So it is 2y by delta. And next, a cubic term. If any cubic terms are there, you check other than 8y cube by delta q. There are no other cubic term. So minus 8y cube by delta q. And now y power 5 is there. You check if any y power 5 terms are there. So there is one more y power 5 term is there, minus other than minus 2y power 5 by delta q. There is one more 4y power 5 by delta power 5 there. So minus 2 minus 4 is minus 6 y power 5 by delta power 5. And the y power 4 term, check, there are two y power 4 terms. So 8 plus 4, it is 12 y power 4 by delta power 4. And there is one minus y square by delta square. Check if any uh, fourth degree, any second degree terms are there. And other than minus y square by delta square, there is no second degree term or y raised to 2. And therefore minus y square by delta square. And already y power 4 term is written and y power 6. Now y power 6 is there. If there exists any more y power 6 term, check no y power 6 term other than y power 6 by delta power 6. So it is only one term. So y power 6 by delta power 6. And already y power 5 uh, has been written. So minus 2 minus 4 minus 6 y power 5 by delta delta power 5. So in the right hand side, what you have to do is what all the terms have been checked. For example, delta terms. You write delta and a mark it tick and delta square a tick, delta cube a tick, delta power 4 a tick, like that. So that which terms are completed, you can conveniently cover. So in that way, the algebra has to be done very carefully. And after this, you have to then simplify this by substituting 0 to delta. And there is uh, no term without y. So all the terms have y in it, and therefore the lower limit has 0 value and only upper limit. So when it is substituted, of course here, and one more thing here is you have to, of course, uh, write, write simplification by taking LCM sometimes. And here also there is uh, there are some terms. Here you see delta square by delta minus delta cube by 3 delta square minus 2 delta power 4 by delta cube plus 12 delta power 5 by 5 delta power 4 minus 6 delta power 6 by 6 delta power 5 plus delta power 7 by 7 delta power 6. So in this way, you get the value delta minus delta by 3 minus 2 delta plus 12 by 5 delta minus delta plus delta by 7. So there you have to take the least count. So here all the denominators have uh, odd and prime values 3, 5, 7. So the you have to multiply to get LCM 7 into 5 into 3 is the LCM 105. And ultimately 105 is the LCM. And you have to do the algebra and get the value finally. The value of energy thickness 22 by 105 delta, which is energy thickness for the given velocity profile. So in that way, these problems play a major role. And in the examinations, sometimes here, though the problems look easy, they require careful manipulations. Okay, we'll end this section here.